Mhm.
Yo, what's up?
Good morning.
Wow, dude, I think I was talking without ever. So I was, I don't think y'all heard me at all. Okay, I was
I
reading
thought
out.
you were doing that on purpose this whole time.
Oh my gosh,
I
no.
just thought your mic broke or something.
Hey, sure, let me be back, everyone. No, my mic is fine. So, wow, I was here talking to myself. Okay. Well, actually, I was talking to my little group I have here, but let me be back, everyone. So basically, if you haven't answered the check-in, please do, so I can mark you here. I'm gonna get you some of these printouts I made. Yeah. So this is if you want. Basically, like I print out the expired, if you like to follow along, like write notes if you like. You don't have to. Big ideas packages if you want a copy and also if you want to Okay, I am now back and finally not muted. Thank you so much. That person who told me you can't hear me, maybe you saw my mask moving and it's like nothing's coming up. Okay, we got yeah, and we got I don't have a routine. Okay, so I see Miles here. I see Jalen's here. And we're getting a few more coming in. Only for like the palette and stuff. But yeah, like if yeah. Yeah, go ahead. But you could also look up here too, but it's like so much stuff on my screen. Okay, cool. And then we got, hey, I'm here. I see you, Tori. I got you. All right, so this is who I am missing right now, y'all. Please correct me if I'm wrong. I base this off the chat, everyone. So I'm missing Brenda, Denise, Brandon, Alexander, Carlos, Ruben, Kyla, um, Zion, yeah, Isa, Leon, Sincere, Celia. So if I made an error, let me know. But I based this off the checking question. So once more, let me go. I actually see Brenda just came on in. So I'm missing Denise. I'm missing Brandon. I'm missing Alexander. I'm missing Ruben, Carlos. Oh my gosh. Oh, do you got earphones? Okay, okay, perfect, perfect. I had some extras. Um, Kyla, Zion, Yaisa, Sincere, and Celia. So that's okay. We got some more. Okay, we got Alexander and we got Ruben. I see you all in the chat. Thank you so much for that correction. So let's go. We got Alexander, we got Ruben. Awesome. If I messed up on anyone else, please let me know. I'm gonna go ahead and transition this and I'm gonna mark my in-person folks as well right here. We have to use different attendance things. There we go. All right. Let me get rid of these things. Now let's get started. So welcome everyone. Let's go ahead and see what we're doing today. Who's coming in? Oh, we got Brandon coming in. Okay, so this is what we're doing, everyone. So I just took attendance a little bit chaotically. I'm getting used to stuff. We're going to be learning about waves and their properties today. So there's going to be Padlet for credit and also there's going to be a Google form. Next off, we'll have a little checkout. Some things you should know. Mini final has been posted due Wednesday. Though due Wednesday is kind of like initial draft. I mean, the last day of our actual class is Thursday. So, I mean, we might have time to, talk about it and have it due Thursday. Big ideas packet has already been posted. So, those are just some major things. Let me know if anyone has any questions about that. So when I say mini final due Wednesday, it's mostly talking about a draft, not like your final. But of course, I'll be taking them in as well on Thursday. Yeah, tomorrow at the end, midnight. Yeah, I know, don't worry. We'll get some support. If you have any concerns about that, don't worry. I got my office hours. If you want to come into my small groups, I have those too. But let's see, is anything coming up for anyone? I mean, initially, this is on Wednesday. This is set for Wednesday, but you know how I am. I might push this to Thursday. So mini final this week, basically. Mini final this week. Does anyone have any questions about that? If you want, once, I don't know if we might have time to, like if I had like everyone annotate, you could. That does help to annotate it though. That would be, yeah. Oh, wow. Someone just asked that question. Do we have to annotate our packet? I don't think we'll have, unfortunately, due to the timing, we have either tomorrow and Thursday. If we do some annotation, it's going to be whole class. So that is a great question. I actually had that asked in person and also online. So that's awesome. Great. Anything else coming up for anyone? Cool. And if anything comes up, just let me know. But let's go ahead and get started with our little, oh wait, there's actually something coming up. Mark me absent, but I was here. Yeah, I think it was based off the check-in question, but if you actually answer that check-in question, I apologize. Let me go ahead and fix that. You are now present. Okay, cool. So let's go ahead and get started, everyone, with what we're doing. So a little quick recap. In our last class, we had a little Desmos, and you also had an asynchronous assignment. It's kind of blurry. Where we talked about how the motion of a windmill connects to a wave. So that was what we did last time. Yep, let me fix this up. And today we're going to kind of finally learn how to kind of construct the creation of an equation from a wave. So this is what we did last time. It was pretty interactive on the Desmos, if y'all remember. And I want to show you something. So at the bottom, what just popped out is actually the equation. This right here is an equation that represents this here wave, actually. So far, y'all, we haven't seen the equation yet. So this is actually the equation now. So that's something new. So we're going to be talking about equations today. Next, remember the Ferris wheel, everyone? We initially started talking about how waves are formed by talking about this Ferris wheel. So we saw these pictures before, but now at the bottom, what it popped up for you is actually the equation that represents this wave. So notice how it kind of looks slightly different from the other one, the windmill one. These numbers look a little different. So actually how we're going to start off today's class is we're going to take a look at both the Ferris wheel and Mr. Windmill right here. And we're going to go ahead and see what we have similar or different. So, oh, notice and wonder. We're going to be doing a Padlet. So what do you notice and wonder about the equations, the windmill one and the Ferris wheel one? So I put them side by side right here. We're going to click on the Padlet. And I'm going to get this for folks in the chat. And then I did see a few direct comments there. So don't worry, I'll get to you once everyone's on the Padlet so I could address your concerns. And let's all go to the Padlet. Once your Padlet loads, right, I'll let you know which column we're going to be at. There we go. Okay, so it looks like, well, okay, it looks like Danny's there already. So we're going to be on column number 5, and you're just doing a notice and wonder on the equation. So focus on the equation. So notice how this equation is just y equals sine x plus 2. Notice how this one is a little bit longer. Go ahead and put down what you notice and wonder additionally from what I just pointed out. You're either going to put your name or we have like down here your initial. Awesome. We have 3 folks there on the Padlet. Yes, today will be for credit. Get yourself on that Padlet. Let's have about a minute or two, and then we're gonna come back and see what y'all think about this. All right, everyone. If you're still typing your comment, feel free to go ahead and finish up your comment. I'm gonna go ahead and start to take a look at the different trends that y'all were noticing. So one of the notices were that, let's see, a lot of you noticed that they both have sign or that little sin in front of the function. So that is a commonality. I noticed that more than one student had said that. A lot of you noticed that the second one had a more complex looking, kind of like it was longer, right? And we have some wonderings uh, if they relate in any way. Oh, okay, this is new. Notice that both equations have the number 2 in it. I actually didn't notice that myself. Now I'm curious, is there really a 2 in both? So this has +2, and this one down here does have some 2's right here. I see that 2 now, so I actually didn't notice that. All right, let's see. We got the Ferris wheel inputs. I want to definitely highlight this one here. The fact that they both spin on a circle is actually a new notice and wonder that I like. They both are spinning on a circle, Ferris wheel, windmill. So the motion of a circle. Oh, okay. So I like this one. So for the first equation, there's a +2, and then for the second, there's a +86, kind of like at the end of it, if y'all notice that. And there's some wonderings about what they might represent, and there's some talk about the y-intercept. And we got the mentioning of the sign. Can we simplify the second question? That is a good question. And we'll probably learn that today, hopefully. And we have a few that are still typing. So again, if you're anonymous, just make sure you put your name or initial so you could get your credit here today. All right, so these are amazing. So thank you so much, y'all, for sharing your thoughts about this. And yeah, let's go ahead and transition from here, and let's learn a little bit more about waves and their equations. Let's go back to our slides. And I am going to go on, oops, someone's trying to join here. Alexander. Let's go to slide 7, everyone. So here is the start of what we're learning here today, trig functions and their properties. And let's take a look at the learning target. I can transform sine. So you all seen the sin or whatever in front of the equation. That's called sine. But there's also something called cosine. We could transform both of these to model different situations. So far, we've been modeling stuff on a circle, just like it was mentioned in the Padlet, like stuff that rotates. So a Ferris wheel, windmill, there's other actual things we could actually model. So take in that learning target there. Okay, let's go ahead. Is that in there? I hope. I was like, is that in there? Okay, perfect. Cool, cool. I just thought I misprinted it. Okay, y'all, let us actually start with what the definitions are when you're, and we're going to talk about sine. Yes, there's also cosine, but cosine is very much related to how sine is. So the first number in front of the sine is actually your amplitude. So y'all notice how in the windmill and the Ferris wheel, the first number was different. That first number is representing the amplitude, as you can see visually. Oh my gosh, I'm like pointing to the board. Okay, let me also use my mouse for those at home. So amplitude right here, green number, the number in front of the sign is representing amplitude. Next one, your B. Now B is a little bit different. It's a little bit more intuitive, but basically the period is, it starts the same way in how we usually measure period. We measure from peak to peak, except there's going to be this new formula that we're going to be using, 2 pi over B, and we're going to be able to get this B term. So your period, as y'all can see, kind of measures how wide or close together your waves are. So that's your B. Next one, you have X minus C. Now C, if you go down here, represents phase shift. Now what phase shift is, it represents side to side shift. Like if your wave got shifted to the side, when I say shift, I'm talking about horizontal shift. So side to side, not up and down. And lastly, vertical shift. That right there is your D term. So that's basically where your, what we call this is the midline of your function. But vertical shift is basically telling us if your wave moved up or down. So that's up and down movement for your vertical shift. Whereas C is side to side. So the difference between C and D. C side to side, D up and down. So those are actually what they represent. And that is why the Ferris wheel had a more complicated equation. It had a different amplitude. It had a different period length. It looked a little bit more scrunched together. I think there was a phase shift in it. Yeah, there was a phase shift. And there was also even a vertical shift. So that's why the Ferris wheel had something that looked long. Now to go back to that Padlet question, can we simplify it? Actually, no. So sometimes you're gonna have messy looking numbers for A, B, C, and D, and you can't actually simplify it. They're just there because they represent something like amplitude, your period, phase shift, or any vertical shifts. So there are our definitions. Let me know if anyone has any questions. I mean, it would have been nice if people at home could see my board, but it's like, I know it's like a glare, so it's very hard to see it. All right, cool. Let's go ahead and move on from these definitions. And now let's go ahead and that I kind of verbally already explained. So again, Ferris wheel stuff. I actually wanted to jump in and probably talk about amplitude actually before we move on. So how would you find the amplitude? I'm going to show you based on this windmill. Usually when you're finding the amplitude, you need to actually count from the middle. What we call this middle line is called your midline. We're going to have definitions real soon for you. It's going to be written on the slide, but, and for those with me, I mean, feel free to draw as well if you'd like to. I'm drawing my midline. So you start by drawing a midline in order to find the amplitude. I'm right now talking about this A term. The next thing as shown in the picture right here, you go from the midline up to a peak. And you basically count the distance of that line. Let me go ahead and show you what I mean here. So from the midline to a peak in green, that measurement, the length of this green stuff, that is your amplitude. You could even go opposite like this way or up this way. And you know, you could keep going. All of these are going to be the same though. They're all the same measurement. So the amplitude for my my little windmill right here is going to be whatever this length is. And what that length is you basically, all you got to look at is your y values right here. See, here's your x, here's your y, x, y. All you got to do is actually take your 3, subtract your 2, and you get that the length right here is 1. You just subtract the heights. So subtract the toppest height from your midline y value, and you get that this has a length of 1, and they're all going to be 1. These are all amplitudes. So if you were to go back to the Ferris wheel one, you're going to see why that amplitude, if you go back, is 86. If you were to actually look at the picture, you would to make your midline and you count, you're going to get that it has a higher, taller amplitude. So that's a little bit of a discussion about our A. We're not going to discuss B, C, and D yet for our little windmill. Okay, there's 4 things in the chat. Let's see. Oh my gosh, it says you muted yourself. I hope you all can hear me. I didn't see
We
my
can.
chat. Okay, great. So it just started. So it just started Y value. Yeah, just look at your Y values for your amplitude. Stand to the side and we'll be able to see the board without the glare. Am I? Really? That's smart. Yeah, I also do have this iPad thingy that I could use, but you know, I think I'll test it for my next class. Thank you so much. Then we have Nev dead. I don't know. So let me know if I addressed any questions coming up for us. Yeah. Oh, what are we subtracting the 3 from? Good question. Once I set up the Padlet, I hope I could do this. So you see this 3 right here, the maximum or highest value of 3? You're subtracting it from wherever your midline Y value is at. Your midline is going to be basically where that intercept is at. So 3 minus 2, that gives you 1. Great. So I had a in-person question. Let me know if anyone else has any clarifications, about how we got the amplitude. Okay, awesome. So let's go ahead and move on. So that's just a little talk of that. It gets pretty complex once we talk about B, C, and D though. So let's go ahead and move on from there. Let me clear my drawings and let's go. Oh wow, y'all, I actually had annotations where I did this, but anyhow, let's move on. And then that's a little bit talk about how we get our period, but we'll talk about that in a bit. Okay, everyone. So one thing that we should know are what are our parent functions? So that's like some important definitions to know, because we're either going to be doing sine or we're going to be doing cosine. A lot of people prefer sine because they're very used to it. So this is what sine looks like, everyone. Notice how your input could either be radian measure, see the pi's down there, or it could also be degree measure. Or sometimes your input is time. Sometimes it's over time, like the Ferris wheel. Notice that the sine, there's a little description. Sine has this up and down curve. It repeats every 2 pi radians, or basically every 360 degrees. It starts at 0, so it starts right here in the middle. It goes up and then goes down. That's sine. Next parent function that you might use is cosine. Cosine starts at the very top and then goes down. Notice its input could be radians or it could also be degrees. Here's its little description. Just like sine, except it has a different starting position. It starts at the very top at 1 and then heads down. So let's see if there's any questions about these like definitions of what sine and cosine are. All right, I don't see any questions popping in for us. So I'm gonna go ahead and take us to the next one. So, okay, great. So I went ahead and kind of just threw out some definitions verbally, but let's go ahead and have them down actually. So here's just two different kind of waves. You could notice that the amplitude on this one's 1, the amplitude of this one's 2. They have different vertical shifts. You could feel free to take a look and kind of compare what's the same or different, but here's some definitions. The period is always the length of one cycle, and we discussed period a little bit, like how to measure it. That's the length of one cycle. Next thing, amplitude. That's a distance from the midline to a peak. That's what I just showed you with the windmill. Phase shift. That's the horizontal shift from either left and right from the usual position. So if you look right here, this one has a little phase shift. It moved to the right by 0.5. So instead of starting from 0 right here, it moved to the right by 0.5 units. Vertical shift is how far the function has shifted vertically from its usual position. So notice how this one has a vertical shift of 0, but the one over here got shifted up by 3 units, so it's higher. Lastly, we should also know what the midline is. That is the horizontal line that passes in the middle between the maximum and minimum. So kind of how I drew that line when we talked about the windmill, that's your midline. Let me draw it in black for both of these. So midline, see how it's directly in the middle between a maximum and a minimum. It just cuts it in half. This one's midline would be right here. Those are the midlines. And again, there's our definition. Let's see if anyone has questions about these definitions here. Okay, so looks pretty set. Cool, and if any questions come up, feel free, let me know. Let me clear up my screen because I drew a little midline. Now then, okay, so I gave you a bunch of definitions. We talked a little bit vaguely. Now it's time to use some of the formulas that you're gonna have to use. So that is where the math kind of comes into play. So here are the formulas, everyone. So we got for sine and cosine. So for sine and cosine, the formulas are going to be the same. Your amplitude is going to be absolute value of A. Your period has a formula 2 pi over the absolute value of B. Phase shift is C over B. We got vertical shift is just that D term, that very last term. And frequency is going to come up in our mini final. That is defined as 1 divided by P, your period. Now on this side, I know nothing popped out. The formula looks very similar, except this right here is tangent. Now, unfortunately, in this module, we're not going to have time to talk about tangents. So that's just there for your reference. If you are interested to learn a little bit about how tangent is different from sine and cosine, feel free. But for our general focus, we're going to focus on these formulas right here. So for sine and cosine, these are the wave formulas. All right, so let's go ahead and talk about how we would actually apply this though. So we got a bunch of formulas. What do we do with them? Let's do an example together. Yeah, so unfortunately for my end student, the printers don't have colored ink, so it's not color coded. But if you have color, like feel free to like color code it. But what had happened is I color code my A as green, B is blue, C is orange, D is red, just so we could follow along on what's doing what and so forth. So let's go ahead and do this. So we're going to create the equation for this graph. And we know that this right here is our parent function. So we need to find A, B, C, and D, everyone. Let's start with A. Oh, well, there's my parent function. And down here is the formula. Now let's start with A. So remember, everyone, in order to find amplitude, if we go back to our little formulas, amplitude is found by first drawing your midline that cuts directly between maximums and minimums. So step one is draw your midline. So right now we're trying to find A right now, everyone. So I drew a midline. And what you want to do is you calculate what's the distance from a midline to a peak. That's going to be our A. So I look down here to my y-axis. So use your y-axis when you're doing this. So I know my midline is at a y value of 1, and a maximum is at a y value of 2. I'm going to do the same thing I did before. We could subtract the 2. So 2 minus 1 means this has a length of 1, everyone. So the amplitude is 1. You could also do it for this one, and you'll see that the amplitude is also 1. But all the amplitudes should be the same. They're going to give us 1. There we go. So we already got the first part. We got 3 more to go. And yes, Danny, so 1. That is correct. Awesome. So let's see if there's any clarifying questions on how I found the amplitude. Now, oh yeah, I wonder if anyone's wondering about the fact that the amplitude formula has an absolute value on it. So basically, absolute value just makes whatever number you have positive. So amplitude is just always going to be positive. I counted 1, so my answer is just 1. To be honest, I did not even actually pay attention to the absolute value because I just know it has to be a positive number. And then, so Danny put, so do we have to put it since it's just 1? No, you don't. Notice how I didn't do it. I just counted my amplitude. I think when you would use it, Danny, though, I wonder if people were to count in this direction, they might get a negative number, and that's why they might need to use the absolute value. In general, though, I don't use them. I just kind of use this, and I know how to count from midline to my maximum. Great questions coming up for us. All right, let's transition to the B term. That's in blue. Notice how it's also color coded down here for us. So it tells us kind of like what formula we need to use. So period is equal to 2 pi over B. Okay, so what you see popping up here is I put the period is the same as the parent function. No, what do I mean by that? So let's kind of go back into the, remember y'all how we had some trouble with how to calculate period in this class. Actually, so let's talk about that again. So how do I know the period is 2 pi? So I'm erasing the amplitude work now. So how do I know the period is 2 pi? So remember all, how do we measure the period of a wave? What you do is you measure the distance from peak to peak. From here to here. Now, I have no clue what this distance is. Actually, if I was to just draw a line, I'm like, what is that distance of this line right here? So a strategy that I like to steal from a student that they did on their little Google form thing is they basically counted the boxes between one height to another. So they did 1, 2, 3, 4. But pay attention, everyone, that does not mean your period is 4. What that means is you have to go down to your x-axis, use your x-axis as a ruler, count 4 boxes and see where you end up. 1, 2, 3, 4. See how I ended up at 2 pi? that's telling me that my period is 2 pi. So that's where I got this. So let me pause and see if anyone has any questions about how I got my period being 2 pi so far. Can you do it one more time? I have a request. Yeah, I could do that one more time. Next time I'll try to set up the palette so I could actually show the board better. I know I could if I step aside, but I know I'm gonna forget and I'll start moving in front of it. So let me do it again. So as a little reminder, everyone, how you measure period is you count the distance from a peak to another peak. So I'm gonna steal a strategy I used from a student. What they did is they counted the boxes. So they're like, okay, from this to here, I'm gonna count how many boxes. So 1 box, 2 box, 3, 4. It took me 4 boxes to get from this peak to this peak. But what does 4 boxes represent? It's not our answer. You have to actually go down to your x-axis. Use your x-axis as a ruler. So we're gonna count 4 boxes down here and see what it actually represents. So 1, 2, 3, 4. Once I counted 4 boxes, the x-axis tell me that 4 boxes represents 2 pi. So my period length is 2 pi. So there's my redoing of that one there. So far, that's our first step for getting our B term. We still haven't yet solved for B, but we all need to be on the same page as how we know that my period is 2 pi, first off. Yeah. Yeah, when you get the period, that's right. So basically, another way to rethink of this, everyone, is like how you count at the top is how you count at the bottom. But when you do it at the bottom, just make sure you start at 0 when you're using that x-axis as a ruler. Great question. Okay, now that we have our period, everyone, I'm gonna go ahead and use the period formula to figure out what in the world my B term is. Here it is. Period formula, it's in blue. Let me just write it right here. Period is equal to 2 pi over B. There's that absolute value thing again, everyone. Again, I'm generally not going to really pay attention to the absolute values just because I know everything's going to be positive. But it's just part of the formula, so it's there. Oh, and then Danny, so Danny did, wait, Danny, is that you describing how you found your B term? So my next step, everyone, so go ahead and put in the chat, Danny, what to explain that. So the next thing I did, so okay, great. I identified that I need this blue period formula to find my B term. What I did next is after I found my period, notice how this P became 2 pi. So I simply substituted now. This P became 2 pi. I just substituted whatever was my period right here. So this P, I replaced it with 2 pi because we figured out that the period is 2 pi. Now what we're gonna do, y'all, is we need to go back and revisit some algebra skills. Like, how do I solve for this B that's down here? This B is kind of stuck. Let me draw that. This B is stuck down here. So I need to figure out a way to solve for that B. But one way to do it is let's try to cross multiply. That's a strategy when you have a fraction like that. How you cross multiply is, first off, make sure that for your left value, put it over 1. Put your left value over 1, as you see there. Then once you have that set up, you can cross multiply. So I'm going to go ahead and cross multiply. So the absolute value of B is going to multiply to 2 pi. 1 is going to multiply to 2 pi. Once you do that cross multiplication, you'll have this. See how 2 pi B is on this side equals 1 times 2 pi is just 2 pi. Now we're at this step. We're actually almost done. I just need to solve for B though. I wonder how we do that. How do I get B by itself? Oh, we already have an answer? Someone said cancel both 2 pi. Someone said cancel both 2 pi as an answer. And then is B 0 question mark? I wish I could ask, and this was a private message, but cancel out 2 pi. I'm curious about that. So again, our goal is we need to get this by itself. This right here is in the way. This 2 pi times your absolute value of B is in the way. How can I get rid of that 2 pi is the question. So I could solve for B. Okay, I have an answer there in the private chat. Yeah, yes. We got, okay, we got actually a bunch. So 2 in the private chat said divide. Could you divide? Or we have divide by 2 pi. So it has specific division. And then we have there from Danny, minus 2 pi from both sides. So I'm going to go ahead and explain. So the answer is indeed divide. We actually can't subtract 2p from both sides because, sorry, 2 pi, not 2p, 2 pi from both sides because 2 pi is still connected to the absolute value of b. If I subtracted, for example, 2 pi maybe over here, I wouldn't be able to subtract them because they're not like terms. So actually, we will divide. So I am just doing my little division sign here very crookedly. And you'll see why division works. Take a look. When you divide, these will cancel out because 2 pi divided by 2 pi is 1. And you're going to be left over with just b is equal to 2 pi divided by 2 pi. Yeah, and then Danny says, I forgot they were being multiplied together. And we have, so b equals pi. Well, let's see. So we got, well, what's anything divided by itself, actually? Like, let's say I have 3 divided by 3. Usually that becomes what? This one's close. I wonder if anyone has any ideas what 2 pi divided by 2 pi is. We have some ideas that b could be pi. I see the pi right here, definitely. Let's see. Let me take, oh, okay, there's like 2 more suggestions there. Okay, so we got publicly, Brenda and Danny are saying 1. Is it just 1? And there's a little bit of uncertainty there. Okay, awesome. And I'm sensing there's a bit of uncertainty because it's like the first time we're doing kind of like math with these pies. Well, it's not the first time. I know y'all did it in geometry, but kind of like more where you're expected to like really be manipulating pi and stuff. But basically, yeah, the answer is going to be 1. The reason why is you could think of what's anything divided by itself. Anything divided by itself is always 1. Or you could have saw like 2 divided by 2, that's 1. Pi divided by pi, that's also 1. Since they all go away, 1 times 1 is just 1. So your B term is indeed just 1. So then maybe some of you are thinking about the Ferris wheel and the windmill. The windmill didn't have anything in front of its x, the equation. So that means it probably had a period of 2 pi. And that's why it was a little bit more simpler. When your period is not 2 pi, that's when your B looks kind of crazy. It looks like a decimal, or it looks large. So our B value, everyone, is going to be 1. So B is equal to 1. Again, we could just say B is equal to 1. So we have A, we have B, there's C, and then there's also D that we still need to figure out from this. And then let me take a look at my, okay, great. Okay, so let's see if there's any questions though about how we just got our B. If anyone has any popping up. Anything like that, just feel free. Okay, everyone, let's talk about that C. So if we look down here, C is an orange. There's a formula called C over B. But before you actually jump into the formula, you got to actually ask yourself, like, is there actually a phase shift happening? If there's no phase shift happening, you're going to be doing work that you don't need to do. So phase shift tells us that our function had moved from side to side. That means left or right from its original starting position. Let's look here. So sine starts in the middle on the y-axis. Specifically, it starts at 0, 0. This is the parent function. I'm just comparing this new function to the parent. So then I kind of identify the very same point on here. It starts in the middle and then goes up. This point is represented by 0, 1. So the points do look different, and perhaps you're thinking, yeah, there's a phase shift because the points aren't the same. But actually what you want to focus on when it's phase shift side to side motion is your x value. Your x value is that first number. If your first number is the same, notice how x is still 0. You do not have a phase shift. So maybe we should type that out. If your x value is the same, you don't have a phase shift. And thus, you don't have to do all that extra work. You don't have to use this actually, because you could simply say, since there's no phase shift, oh, I didn't write it down. Since there's no phase shift, we have that your C is equal to 0. So I don't know why it didn't pop up. C is equal to 0 right here. There is no phase shift. And I did not have to use the phase shift formula. You could, but you're going to do yourself extra work. So there is no phase shift because the x value is still 0. The starting x value is still going to be at 0. Let's see our time. Okay. Oh yeah, huh, lunch is almost happening. All right, y'all, we have a few minutes. Let's talk about the D term. Then hopefully have time for a checkout, I think. And then let me know if anyone has questions, by the way, about C, if they're coming up for you as well. Lastly, everybody, let's talk about D. How do you figure out D? So D is basically, everyone, let me just tell you already, your vertical shift is basically the Y value of where your midline is located at, if that makes sense. So let's draw the midline again. Yeah, sure. So this is your midline, everyone. Notice that it's at a Y value of 1. That tells me that my vertical shift is 1. It's wherever your midline is at on the Y axis or on the Y coordinate. That is your vertical shift. The midline intersects the Y axis. So I'm going to leave this up for folks who still are getting this down, because I know are in person, but people over here are heading to lunch, everyone. So I think we'll hold on the checkout. What your checkout could go ahead and be, hold on to any questions that you have about this, and we could come back and talk about it tomorrow. We're going to be meeting tomorrow, so just take a look at this, hold on to your questions. We'll come back to this tomorrow. Bye, everyone. Enjoy your lunch.
All right, see ya. Bye.
Bye. Sorry, my bad. Because what was that?
Miss Adano, can we talk?
Yeah, we can totally. Okay, I was gonna run and get some lunch. No, I mean, let's see. I wonder if they allow it. I mean, that's cool with me. I don't know if Younger could allow it. So you said you're meeting with who? Carla. I wonder if, I mean, let's see. So let's see if Younger says yes, that could be cool. What was that? Yeah, that would be great. And what time is your meeting with Carla? At 12. At 12. Oh, like right now, okay, so that, yeah. Yeah, I'm hoping that works. And then this is for Kyla, right?
Yeah. Hey, Mr. Dono.
Hi.
I'm sorry about not joining your small group today. I told Miss Rayvon, I have a lot of home situations going on, and I wasn't going to be able to participate. But
Right.
like to, conversate with you in the time about it. But I understand. I'm gonna come to your next office hours.
Okay, that would be awesome.
Also, I was marked absent.
Oh, don't worry, I'll go ahead and update that right now, okay? Because
Okay.
sorry, my bad.
It's fine.
Let me update that. And bye, Rachel. Thank you so much. I hope to see you soon. Okay, sorry, my bad. Okay, okay, so I do have office hours, I think today, if you're interested. Or you could also jump into, because I know my small group is a little bit tricky for tomorrow. So unless you want to reach out and let me know another time that works too, because I heard you're also might be going through stuff. So if right now is not a good time, we could also schedule for the future too, Kyla, if that works for you.
Okay, thank you so much, Mr. Dono.
Yeah, I'm happy.
I'll come to the small group because office
Okay.
hours today. I don't think
So
I will be able to make it.
let's do the, okay, perfect. So let's do the next small group. Let's do the
Okay.
next one. And I think it should be next week.
Okay,
And I'm hoping
sounds good.
things clear up for you on your end by that time, I'm hoping, but yeah.
Thank you.
You're welcome. Thank you so much for checking in. I'll go ahead and fix your attendance. All right. Yeah, I hope today's lesson made some sense, Jasmine. Everyone gets a little lost once the math comes up. Oh my God, I took off my mask. I'm sorry, I forgot. It's okay, well, okay, that's good. So at least like kind of having your own copy kind of helps, right? Oh gosh. Oh my
It
gosh.
was so weird because I had the same symptoms. Like, how am I gonna lose the smell of the taste of it?
Really?
Yeah, and it was so weird. And like, how,
And you had your shot, right?
yeah, and my sister had got tested positive like 2 months ago.
Oh,